Next sum is sum number 11. For a LTI system, y of n minus 1 by 3 y of n minus 1 is equal to x of n, and x of n is equal to half raised to n u of n. Find y of n. Okay, quite a famous sum, it often comes. Okay, so y of n minus 1 by 3 y of n minus 1 x of n. What is the z transform of this? Y of n is y of z minus 1 by 3. What is y of n minus 1? It is your famous property of shifting. Okay, so that is z raised to minus n naught. What is n naught? 1. Y of z is equal to x of z. So take your y of z common. Y of z is 1 minus 1 by 3 z inverse is equal to x of z. Therefore, y of z upon x of z is equal to 1 upon 1 minus 1 by 3 z inverse. Alright. So if I talk about an LTI system, LTI, if the impulse response h of n, input is x of n, output is y of n, what is the output? Y of n is equal to x of n convolution h of n. Okay, what is the z transform? Y of z is equal to x of z into h of z. Therefore, what is h of z? H of z is y of z upon x of z. So use the same over here. This is equal to h of z. So y of z upon x of z is equal to h of z, please. So I have h of z. Now I have x of n. I need to find y of n. Fine. So I have with me h of z. H of z I have with me as 1 upon 1 minus 1 by 3 z inverse. X of n is given to me as half raised to n u of n. So what is x of z? X of z is 1 upon 1 minus 2 z inverse. And I need to find y of n. I know that y of z is equal to x of z into h of z. X of z is 1 upon 1 minus half z inverse. H of z is 1 upon 1 minus 1 by 3 z inverse. You take the partial fractions, a upon 1 minus half z inverse plus b upon 1 minus 1 by 3 z inverse. You will get this as 3 upon 1 minus half z inverse minus 2 upon 1 minus 1 by 3 z inverse. Therefore, this is your y of z. Therefore, if you take inverse Laplace transform, therefore y of n is equal to, what is it? 3. What do we write? Half raised to n u of n minus 2 1 by 3 raised to n u of n. So this is your final answer. This is the answer of y of n. On the similar lines, we will do the 12th sum. X of n is equal to 1 by 2 raised to n u of n, and y of n is delta n plus 1 by 4 raised to n u of n. Find h of z. We know that y of n is equal to x of n convolution h of n. Therefore, you get y of z is equal to x of z into h of z. Therefore, h of z is equal to y of z upon x of z. Yeah, I know what is x of n. X of n is half raised to n u of n. So what is x of z? 1 upon 1 minus half z inverse. Okay, I know what is y of n. Y of n is delta n plus 1 by 4 raised to n u of n. So what is y of z? Y of z, delta n transform is 1 plus 1 upon 1 minus 1 by 4 z inverse. So you have got y of z, you have got x of z. So what is h of z? H of z is 1 plus 1 upon 1 minus 1 by 4 z inverse upon 1 minus half z inverse. That is your answer, please. X of z is equal to a z inverse upon 1 minus a z inverse the whole squared mod z is more than mod a, find x of n. Now how do you solve this? Okay, I will do known. Let x1 of n be equal to a raised to n u of n. Therefore, what is x1 of z? x1 of z is 1 upon 1 minus a z inverse. What is d by dz of x1 of z? d by dz of this entire term. So it is minus 1 upon 1 minus a z inverse squared minus a z inverse is minus 1 z minus 2. So you are left with minus a z minus 2 upon 1 minus a z inverse the whole squared. Alright. So therefore you can say d by dz of x1 of z is equal to minus a z minus 2 1 minus a z inverse whole square. You can take this z on this side. So you'll have therefore z inverse 1 z inverse on this side, so it become z, and this minus also you can take on this side. So minus z d by dz of x1 of z is equal to a z inverse upon 1 minus a z inverse the whole square. Therefore you can say minus z d by dz x1 of z is equal to, what is this entire term? A z inverse 1 upon 1 minus a z inverse the whole square. It is your x of z directly. Right. So now I can take the inverse z transform. What is minus z d by dz of x1 of z? It is n x1 of n. What is x of z inverse z transform? X of n. Therefore, what is x of n? Equal to n into x1 of n. What is x1 of n? You have taken a raised to n u of n. Very good sum. A lot of things to be considered over here. I hope you have understood this. Okay. So our main aim was to get this thing over here so that we can use the sum, and then we are using the differentiation in the z domain to get this answer over here. Okay, let us start off with unilateral Z transform. We have seen bilateral Z transform as x of z as this bilateral Z transform. X of z is summation n is equal to minus infinity x of n z minus n. X of n is taken from minus infinity to infinity. So what is unilateral Z transform? X of z is equal to summation n is equal to 0 to infinity x of n z minus n. Alright, so what is the specialty of unilateral Z transform? That your x of n is from 0 to infinity. In bilateral it was from minus infinity to infinity. That is the only change. Let us do a sum. Find the unilateral Z transform of 3 raised to n u of minus n. Okay, what is 3 raised to n u of minus n? The signal exists from where? From u of minus n means signal is from 0, minus 1, minus 2, minus 3 and so on up to minus infinity. U of minus n, right? What is 3 raised to n? 3 raised to 0 is 1. What is 3 raised to minus 1? It is 1 by 3. 3 raised to minus 2 is 1 by 9 and so on. Now, what is the formula with us? Unilateral Z transform is equal to summation n is equal to 0 to infinity, okay, x of n z minus n. So it is from 0 to infinity, okay. Here there is no samples, nothing, only sample is at 0. So I will say x of 0 z of minus 0 plus nothing, not to be considered. What is x of 0, guys? It is 1. 1 raised to z of 0. The answer is 1. Therefore, x of z is equal to 1. If I say find the unilateral Z transform of 2 raised to n u of minus n minus 2. Fine. What is u of minus n minus 2? U of minus n minus 2, n minus 2 is, so two operations, right, over here. One is delay and one is reversal. So delay will start from 2. This is your u of n minus 2. Okay. What is u of minus n minus 2? It is the time reversal. Fine. So what have we said? We have said that unilateral Z transform is applicable only for signals on the RHS. There is no signal on the RHS over here. So what can you say? You can say that therefore unilateral Z transform of 2 raised to n u of minus n minus 2 is equal to 0. Next topic is initial value theorem and final value theorem using Z transform. Okay, initial value theorem and final value theorem. Just note one thing over here. For IVT and FVT, poles should be inside the unit circle. Let us do a sum, please. Okay, let us write the formula first of all. What is the meaning of initial value? Initial value means x of 0. Initial value theorem, x of 0 is limit z tends to infinity capital X of z. And what is final value? X of infinity is equal to limit, listen carefully, z tends to 1 minus z inverse x of z. Okay, so this is your initial value theorem, and this over here is your final value theorem. Let us do a sum, please. Find IVT and FVT for x of z is equal to 0.8 upon 1 minus 1.8 z inverse plus 0.8 z minus 2. Let us start off with the initial value x of 0. X of 0 formula is limit z tends to infinity x of z is equal to limit z tends to infinity x of z is 0.8 upon 1 minus 0.8 z inverse plus 0.8 z minus 2. The z inverse can be written as z minus 2 can be written as z square. Okay, so if you replace z as infinity, it is 0.8 upon infinity and 0.8 upon infinity square. So what is the answer you get? Therefore answer is 0.8 upon 1 minus, what is something upon infinity? 0. What is something upon infinity? 0. So what is the answer? 0.8. Therefore you can say x of 0 is equal to 0.8. Final value x of infinity is equal to limit z tends to 1 minus z inverse x of z, right? That is limit z tends to 1 minus z inverse. What is x of z? 0.8 upon 1 minus 1.8 z inverse plus 0.8 z minus 2. Okay. So generally, whenever you get a sum like this, your x of z will be in a form which is divisible. So you can write this as 1 minus Z inverse minus 0.8 Z inverse plus 0.8 Z minus 2 is equal to limit Z tends to 1, 1 minus Z inverse 0.8. So we'll have common 1 minus Z inverse minus 0.8 Z inverse 1 minus Z inverse. So you'll have limit Z tends to 1, 1 minus Z inverse 0.8. So 1 minus Z inverse is common, 1 minus Z inverse, and you'll have 1 minus 0.8 Z inverse. So these two will get cut. What remains? 0.8 upon 1 minus 0.8 Z inverse. This can be written as Z, and Z value is 1. So what is the answer? I will put the limits over here. 0.8 upon 1 minus 0.8 upon 1. Answer is 0.8 upon 0.2. That is 4. Therefore, x of infinity is equal to 4. X of n is equal to 1 and 0 for n as even and n is equal to 0. X of n is equal to 0 for n odd. You can say n more than or equal to 0. Okay. Find final value. Okay, let us plot x of n, please. X of n is equal to 1 for n is equal to 0. Okay, 1 for n is equal to 0. X of n is equal to 0 for all odds. So for every even, you will find x of n is equal to 1. And for every odd, x of n is equal to 0. For every even, x of n is equal to 1. So this is your x of n. Right? Okay. So I need to find the final value. What is the formula of final value? X of infinity is equal to limit z tends to 1, 1 minus z inverse x of z. Okay. So I need to find out x of z first of all. So how do I find x of z from this? I will say x of z is summation n is equal to 0 to infinity, because it starts from 0, x of n, z of minus n. So it is going to be, what is x of 0? X of 0 is 1, plus what is x of 1? 0. X of 2 is 1. 1 into z raised to minus 2 plus x of 3 is 0. X of 4 is 1. 1 into z raised to minus 4 plus z raised to minus 6 plus z raised to minus 8 and so on. So if you see the geometric progression over here, this will be of the form 1 upon 1 minus a, that is z inverse. Therefore, you can say x of z is equal to this. I have used this formula right over here, guys. For those who are confused, n is equal to 0 to infinity, a raised to n is equal to 1 upon 1 minus a. Okay. So x of z I have found. Now I need to just find out x of infinity. Therefore, x of infinity is equal to limit z tends to 1, 1 minus z inverse x of z. So limit z tends to 1, 1 minus z inverse x of z I have got as 1 minus z minus 2. That is limit z tends to 1, 1 minus z inverse. How do I write 1 minus z inverse? I can write this as 1 upon 1 minus z inverse into 1 plus z inverse, right? And so this will get cut. So what is the answer? Is equal to limit z tends to 1, 1 upon 1 plus z inverse. Okay, just replace z as 1, so we'll have 1 upon 1 plus 1. So this is 1 by 2. So x of infinity is equal to 1 by 2. So that takes care of the initial and the final value theorems. Fine. So the last topic is causality and stability. We have done this causality and stability when we are doing the standard signals, alright. We have done it for finding different values of ROC. Okay. So what is the meaning of causality and stability using Z transform? Fine. So if I say that a signal system is stable if ROC contains the unit circle, right? And a signal system is causal if ROC is outside the outermost pole. A signal is anti-causal if ROC is inside the innermost pole. Okay. So causal means on the right hand side, anti-causal means on the left hand side. If I say non-causal, what's the meaning of non-causal? On both the sides. So ROC is between intersection of two ROCs. Okay, we'll see what is the meaning of this non-causal, anti-causal and causal and stability by doing one sum. Okay, this one sum should be enough for us to understand the concept behind this entire thing. Okay, you have done this earlier also, but we'll do it once again for your reference. Okay. Well, let us do a sum directly over here so that we can understand what is this causality and stability. If I say, for example, h of z is equal to 3 upon 1 minus 10 by 3 z inverse plus z minus 2. Check ROC for all cases. Check causality and stability for all cases. So we can write h of z is equal to 3 upon 1 minus 1 by 3 z inverse minus 3 z inverse. Yeah. What is the addition of this? You will get 10 by 3 z inverse plus z minus 2 is equal to 3 upon 1 minus 1 by 3 z inverse minus 3 z inverse 1 minus 1 by 3 z inverse, right? You get this, you will get the same thing, right? This is equal to 3 upon 1 minus 1 by 3 z inverse and 1 minus 3 z inverse, right? Okay, so take the partial fractions, you will get a upon 1 minus 1 by 3 z inverse plus b upon 1 minus 3 z inverse. Okay, please do the a and b part. You will get a as minus 3 by 8, 1 minus 1 by 3 z inverse plus 27 by 8, 1 upon 1 minus 3 z inverse. That is your h of z. Fine. Okay. So therefore h of z is minus 3 by 8 upon 1 minus 1 by 3 z inverse plus 27 by 8, 1 minus 3 z inverse. So just write in this way, minus 3 by 8 z upon z minus 1 by 3 plus 27 by 8 z upon z minus 3. Right? So I will have 3 cases over here, right? 3 cases. Just draw it. I will draw it in one slide itself. So my case 1 will be when h of n is right sided, when h of n is left sided, when h of n is both sided. Fine. So if it has to be right sided, both these parts should be right sided. So what is the meaning of right sided? My ROC is mod z. My poles are at what? Poles are at z is equal to 1 by 3 and you can see z is equal to 3 over here. So mod z is more than a, that is 1 by 3, and mod z is more than 3. For left hand side, what should be the case? Mod z is less than 1 by 3 and mod z is less than 3. For the middle one, what will you say? mod z is more than 1 by 3 and mod z is less than 3. Okay, so now if I draw the ROC, let us see how the ROC will look like. Okay, so where are my poles, guys? Please, poles are at 1 by 3. So 1 by 3 is somewhere over here, 1 by 3, and 3 is maybe somewhere over here. Same case for this, 1 by 3 over here, 3 over here, 1 by 3 over here, and 3 over here. Okay, what is the first ROC? First ROC, mod z is more than 1 by 3 and mod z is more than 3. So what is the final ROC, please? Final ROC is like this. So what is final ROC? Mod z is more than mod 3. What about this? Mod z is less than 1 by 3. Less than means over here. And mod z is less than 3. Less than 3 means like this. Okay. So what is the intersection of both? It is just this part over here. And what about this? Mod z is more than 1 by 3 means it is like this. And less than 3 means it is like this. So what is the intersection? It is this part over here. Alright. So what is the final case over here? ROC case, mod z is less than 1 by 3. And over here, mod z is more than 1 by 3 and less than 3. Okay. Let us check the causality and stability for this. Okay. Is this causal? What is the condition for causality? Causality condition is that ROC should be outside the rightmost pole. So what is the rightmost pole over here? This one. So ROC is outside the rightmost pole, right? So it is causal. ROC is outside rightmost pole. It is stable. For stability, what is the condition? That your ROC should contain the unit circle. Does the ROC contain unit circle? No. So it is unstable. Why? ROC does not contain unit circle. What about this case? Is it causal? No. Why? These are two poles over here, 1 by 3 and 3. So it says that ROC is inside the innermost pole. So this is the innermost pole, please. So it is inside the innermost pole, ROC. So it is anti-causal, please. Is it stable? No, because your ROC, this region over here, does not contain the unit circle. So it is unstable. What about this region over here? ROC is in between these two poles. So it is non-causal. Is it stable? See, ROC, it contains the unit circle. So it is stable. This is how you will do the sums of Z transform. So whenever sum like this is given to you, you need to find out H of Z, you need to find out the ROCs and plot the ROCs. Now, if they ask you to plot H of n, you must do it accordingly. If they say find out H of n also, so H of n is going to be, you must take the inverse Z transform of this H of n and then do it. We have done this in the earlier lectures when we were doing standard signals. Okay, you can refer that video to understand how to get H of n for the different three cases. Fine. So this takes care of Z transform. So we have finished off with Z transform also. Z transform is a very important module. Please see to it that this module is done properly. Just see the video 1 or 2 times and you should be good to go. Yeah. So thank you very much.